section 4.3 is on the right triangle definitions of the trigonometric functions. So here we're looking at how the trig functions can be defined in terms of a right triangle. Okay, so if I have a right triangle ABC and I'm looking at angle theta that I have labeled here, we have a side A, which is the side that is considered to be opposite theta. We have a side B that's considered to be the adjacent side to theta. And then C is the hypotenuse because it's the side across from the right angle. So if we're looking at angle theta, we have an opposite side, an adjacent side, and then the hypotenuse. Okay, so by using our definitions here, the sine of angle theta is always going to be the side opposite the angle over the hypotenuse of the triangle. The cosine of theta is going to be the side adjacent to theta over the hypotenuse, and then the tangent of theta would be the opposite side of theta over the adjacent side to theta. And then also we have our reciprocal functions, cosecant, secant, and cotangent, which are just the reciprocal of sine, cosine, and tangent. Okay, so we've looked at how we've defined the trig functions in terms of the unit circle. Okay, here we're looking at how they're defined if you're given a right triangle. Okay, it's a good idea also that you learn these, that you can identify the functions based on these definitions. Okay, so if I wanted to write out what the sine of theta was from this triangle, it would just be A over C. That's opposite over hypotenuse. The cosine would be B over C, and then the tangent would be opposite over adjacent, so A over B. Okay, and then cosecant would be just the reciprocal, so C over A. Secant would be the reciprocal of cosine, so C over B. And cotangent would be the reciprocal of tangent, so it would be B over A. Okay, which of course we know we're going to have numbers representing the sides of the triangle. One topic that you're going to have to be familiar with is the Pythagorean theorem. If you look at number 2, it says find the value of each trig function of theta. Okay, well I have the length of the side that's opposite theta, and I have the side that is adjacent to theta, but we don't have the value of C. So we can use the Pythagorean theorem to find the missing side. So the Pythagorean theorem is a squared plus b squared equals c squared. So I can plug my values in. 5 squared plus 12 squared equals c squared. So that would be 25 plus 144 equals c squared, which is 169, and then take the square root, so c is 13. Okay, so once we have the length of each side, then we can find each trig function. So if I wanted to find the sine of theta, the sine of theta would be the opposite side over the hypotenuse, so that would be 5/13. The cosine of theta would be adjacent over hypotenuse, so 12 over 13. And the tangent of theta would be opposite over adjacent, so 5 over 12. And then if it asks you for the reciprocals, the cosecant of theta would be 13 over 5. Then the secant of theta would be 13 over 12. And then the cotangent of theta would be 12 over 5. Okay, they may not always ask you for all 6 of the functions. It may just be 1 or 2. Just depends on the problem. Okay, if we look at number 3, this is one of our special right triangles that we talked about in the previous section. It's the 45, 45, 90. So I need a right angle right there to show. So Remember we talked about the lengths of the sides. Let's say if the hypotenuse is 1, then the sides are the square root of 2 over 2. So what would the sine of 45 degrees be? Opposite over hypotenuse. So the square root of 2 over 2 over 1 would still just be the square root of 2 over 2. The cosine of 45 degrees, the adjacent side over the hypotenuse, is still square root of 2 over 2. The tangent would be opposite over adjacent. So if I put the square root of 2 over itself, that would just equal 1. And then we can find the cosecant by taking the reciprocal sine. So if I take the reciprocal of the square root of 2 over 2, I would have 2 over the square root of 2, which I would have to rationalize. So 2 square roots of 2 over 2, 2's divide out, and so the cosecant would just be the square root of 2. And then also, the secant would be the same, since the sine and cosine are the same, and the cotangent would be the reciprocal of tangent, which would be 1.